Okay, hi, back for the last three problems. Okay, this next one, we need to turn everything into a common base, and I recognize all of those as a base 5, so this is 5 to the 4x, 5 squared, and this one equals, that's 25, times 5 is 125, times another 5 is 625. So this is 5 to the 4th, and then we also have the 2x that was already sitting there right here. On this side, we have to combine those by addition. So this is 5 raised to the 4x plus 2. And then over here on the right side, since there's only one 5, we have to multiply the powers. And so this is 5 to the 8x. Once these bases match, you can cross them out. So 4x plus 2 equals 8x. And now we're solving for x. X equals 2/4, which reduces to 1/2. Okay. Great. 8 has e's in it. It also, notice it has an x squared, so we might have to solve this one a little bit differently. But right now I'm looking at a positive to this one is that they're already in base e, so I don't have to convert that. I do need to remember this is e to the 4x, e to the x squared times, and e to the 12th. So again, just like on the last problem, when they both have the same base, these exponents can be added together. So this is x squared plus 4x, and then we have e to the 12th over here. When the bases match, all we have to do is set the exponents equal to each other. So we're going to get rid of these, and we have x squared plus 4x is equal to 12. When we were in Algebra 2, we learned that when you have a quadratic which has an x squared in it, you want to move everything over to one side. So subtract the 12 over. And you want the quadratic to be set equal to 0. And now what we're going to try to do, we're going to try to factor. We could do factoring, we could do complete the square, we could do quadratic formula, but most people will try factoring first. See if it's factorable. If it is, that's probably going to be the quickest way of doing it. If you really love the quadratic formula, you could do opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That always works. But it looks like this one is going to factor. So I'd have x times x would give me the x squared, and I need two factors of 12 that will have a sum of 4. And so I'm going to try 6 and a 2. If I had a positive 6 and a negative 2, that would make the negative 12, and then 6x minus 2x would give me a 4x. This is now called the zero product property. So I'm going to take each pair and set them equal to 0. So I'm going to get x equals negative 6 and x equals positive 2. And then, is there any restriction on what my answers can be? No, there's no restriction. I could have positive answers or negative answers. So I need to have both of these. And they'll both work. All right, last one is number 9. All right, so I have e to the negative x squared, e to the positive x squared, And then I have times 1 over e to the 8th, which I know is e to the negative 8th power. That's right here. I just moved it upstairs. And instead of a positive 8 in the denominator, I make it a negative 8 power in the numerator. These two are going to get combined by addition. So it's e to the x squared plus negative 8 would be minus 8. And once I do that, I can now say bases are equal. Once the bases are equal, I cross it out. Negative x squared equals x squared minus 8. And now I'm going to solve this one. So I'm going to add x squared to both sides. 0 equals 2x squareds minus 8. Move that up here. And then since this is a quadratic that doesn't have a linear term or a single x term, I'm going to move the, I'm just going to rewrite this here, 2x squared minus 8 equals 0. I'm going to move the 8 to the other side by adding it over, dividing both sides by 2, and then I'm going to take the square root, which means that x would equal plus or minus 2. Both answers will work. And that's all for today. So I put up some exponential equations on Delta Math. And I want to say I called it practice 10.4 or something like that. But you guys can go in there and try some of these problems. I put like 10 of them up there for you guys to work on and see if you can get them. Okay, good luck.